Hey guys, all right, so let's take a look at the rest of this unit circle. I'm going to actually erase the stuff in the middle of the unit circle so I can use my other special triangle. So let's see, get rid of that. I'm keeping the points though there. You guys eventually have to memorize those points. So let's see if I can fill out the rest of these missing points. I'm going to look at this triangle, this 30, 60, 90, and I'm going to draw it in a different direction just so it looks like what I'm going to put on my unit circle. I still have a 30 degrees. It's just that bottom left corner is 30 degrees and the 60 degrees and the 90 degrees. Okay, so across from my 30 was a 1/2. The hypotenuse was 1. And across from my 60 here was the √3/2. All right, so what I'm going to do is put that triangle on my unit circle here. So we were supposed to memorize our angles. This was our 30 degrees from the origin there. It's at a right angle. Here's my 60 degrees. Okay, so it's my 30, 60, 90. And again, across from the 30 was a 1/2. Across from the 60 was the √3/2. And the hypotenuse was a 1, which should be a 1 because this is the radius of the circle is a 1 all the way around. That's why it's the unit circle, 1 unit. All right, so this x looks like it went over this √3/2. The y, the vertical one there, was the 1/2. So I'm going to go with √3/2 for x and a 1/2 for y. Maybe. There we go. All right, and then I'm going to kind of do what I did with the purple one here with the 45, 45, 90. I'm going to kind of reflect and put the same thing just on the other side, which we already talked about this quadrant. I will have a negative x and a positive y. So you know how my x over here was √3/2? I'm going to go the same distance on the opposite side. This is still a distance of √3/2, but it's an x value. Negatives are negative x values on the left side here. So it's a negative √3/2 and a positive 1/2. So here's my xy point. Negative √3/2, positive 1/2. Okay. And then the ones, get this out of the way here. The next one down here, there's my next 30, 60, 90 down there. The shorter side is still a 1/2. The longer side is that √3/2. This one actually, I went down a 1/2, so I'm gonna have a negative 1/2 for that y value. So here's my x value, negative √3/2. Again, this guy, that x value. And then my y value was the negative 1/2. Oops, let's see here. All right, so you guys noticing it's the same point, √3/2, 1/2, √3/2, 1/2, √3/2, 1/2. I'm basically changing the signs based on the quadrant. So in this quadrant, I'm gonna have a positive x and a negative y. So I'm still gonna have a √3/2 and then a 1/2, but positive √3/2 for my x, negative 1/2 for my y. If you draw the triangle, you still should get the same thing here. Here's my right triangle. Still the same distance of 1/2, it just went down, so it's a negative 1/2. And then this horizontal distance was still the √3/2. So yeah, I got the same point. All right, so that was my 30, 60, 90, which I kind of had, notice I put the 30 degrees at the origin all the way through this. Let's kind of rotate the same triangle. I'm going to use a 30, 60, 90 still. But instead of putting my little 30 degree angle there, I'm going to put my 60 degree angle right here. So let's see, this is 60 degrees at the origin now. My 90 degrees still goes to the x-axis. And then I've got my 30 degrees here. So off of that, I still have this special triangle where across from the 30 is my 1/2, across from the 60 is my √3/2, and then the hypotenuse is a 1. So let's see, across from my 30 is the 1/2. Across from my 60 was the √3/2, and then the hypotenuse is a 1. All right, so my xy point now, I basically swapped my x and y. My x is now the 1/2, and my y is the √3/2. All right, so I'm going to draw that same triangle over here. I still have 60 degrees at the origin got the 30 degrees out on the edge of the circle, and my 90 degrees still comes to the x-axis as usual. So let's see this. Same triangle. I got a 1, I got a 1/2 across from my 30, I got a √3/2 across from my 60. So my x 1/2, y is the √3/2. X 1/2, y is the √3/2. But I'm in quadrant 2 to where my x value has to be a negative. So I'm going to do a negative 1/2. Okay. And then I'm going to keep it going. If I draw this triangle down here, I still have my 60 degrees at the origin. I still have my 90 degrees at the x-axis and my 30 out on the edge of the circle. So I've got my shorter side, the 1/2 is my x. The longer side, the √3/2 is my y. So 1/2 for x, √3/2 for y. But this is in my quadrant 2. They're both negative, a negative x and a negative y. So let's adjust this. Negative 1/2 for my x, negative √3/2 for my y. All right, we got one more. So here is this last triangle that I'm going to draw here. I still have that x value of 1/2. We already drew that right here. The y value, how far down I went, it's like the same distance that I went up, still √3/2. It's just because I went down, I have a negative √3/2. So my x again is the 1/2. My y is the √3/2. In fact, a negative √3/2. Okay, I got a positive x and a negative y. All right, so I'm going to erase all this messy triangle stuff in there. There we go. We used our 2 special triangles to get, we got the whole unit circle actually. We filled out the whole thing. All right, so these are the points that we need to start memorizing. And let's see if we can use that for this question. So it says all points on the unit circle have a radius r of, they have a radius of 1. This is what we were talking about. It's a unit circle, 1 unit. So from the center to the outside, that's a distance of 1. Center to the outside, my radius of the circle is 1 every time. That's kind of why we put the triangles in that we did. We made their hypotenuse be a 1. And the reason we were bringing this up is because you know how, I'll show you up here. You know these trig functions we were talking about on your graph? They got like this r in it, the radius. But we were just considering having a radius of 1. So if I make those all into a 1, this is going to be like a y over 1, an x over 1, like 1 over y, 1 over x. So if I make my radius a 1, that is where these guys are coming from. My y over 1, or plain y, my x over 1, so plain x, 1 over y, 1 over x. And then these guys never used a radius to begin with. They used the x and y, so those haven't changed. Okay, so based off of this on our unit circle, let's see if we can use the unit circle to evaluate the 6 trig functions of 270 degrees. Okay, first things first, let's go figure out where is 270 degrees on the unit circle. Okay, so 270 degrees. First of all, it's a positive 270, so I'm going to go rotating in the positive direction. Positive 270. Let's see, 270 is bigger than 180, so it's more than half a circle. In fact, we should have been memorizing this 270. Ends up down here, actually at this point, 0, -1. This is where we're at. All right, and at that point, if I know that point, I can find all 6 trig functions. My sine, I'm going to do as usual. I'm going to do my main 3 trig functions first: sine, cosine of theta, and tangent of theta. Actually, I already know my theta. My theta is 270. So instead of sine of theta, I'm going to do sine of 270 degrees, cosine of 270 degrees, and tangent of 270 degrees. The sine is the y value. Again, we already figured out this is the point 0, -1, and the y value there is my y, -1. Cosine, all right, cosine of theta, cosine of 270 is the x value at 270, and my x value at 270 was 0. So this cosine of 270 is 0. All right, my tangent of theta, tangent of 270, is the y over x. So my y -1 over x, 0. Small problem, if I do -1 divided by 0, like put that in your calculator, it's like error, there's something wrong here. And actually was a restriction right here. It says x does not equal 0 because my x is in the denominator and I can't divide by 0. So usually they actually call this undefined. If they ever make you divide by 0. Okay, so I'm going to say, here's my sine of 270, -1, cosine of 270 is 0, and my tangent of 270 is actually undefined. So now let's get the reciprocals, the other 3 trig functions. Here's my cosecant of theta, so cosecant of 270 degrees, my secant of 270 degrees, and my cotangent of 270 degrees. All right, so if you want to treat this as like -1/1, you can. The reciprocal of that, if I flip it upside down, I get 1 divided by -1. It's still a -1. All right, reciprocal, flip it. 1 divided by -1 is still a -1. This guy, though, any whole number, you can treat it like it's over 1. I can treat this like 0/1. If I do the reciprocal, though, I flip that, I get 1/0, which, small problem, it's the same thing I had right here in tangent. I can't divide by 0. This is considered undefined. And my last one is cotangent of 270, which is the reciprocal of tangent. I know my final answer on tangent was undefined, but this fraction, if I do the reciprocal of that, I'm going to get 0/-1. That I can divide by -1. 0 divided by whatever is still 0. So that one is defined. It is 0. All right, guys. I'll see you when I get back. Have a good day.